Hi, Assalamu alaikum. In this video, I am going to teach uh, six sequence in theorem number 5, which is listed as the following six sequences converge to the limit listed below. We have sequence 1. Sequence 1 is limit n approach to infinity log n over n equals 0. This is our first sequence. It's mean when n approach to 0, when n approach to 0, basically it's our sequence log of n over n, it's our sequence, and when limits n approach to infinity, when we put n approach to infinity, this sequence tends to 0, give us 0. Similarly, we have sequence number 2, 3, 4, 5 and 6. In sequence 2, the limits tends to 1 as n approach to infinity. In sequence 3, the limits tends to 1 as n approach to infinity. But in the third sequence, we have mentioned a condition which is when this tends to 1 when x greater than 0. When x greater than 0, we get 1 when limit n approach to infinity. Similarly, in sequence number 4, with this condition, when x is between -1 and 1, then the sequence tends to 0 as n approach to infinity. And the fifth one is for any x, there is no condition on x will be 1, 2, 3, 4, anything. Okay, any x, for any x, the sequence tends to e to power x when n approach to infinity. And the final is sixth sequence. The sixth sequence tends to 0 as n tends to infinity. Okay, next going to show the proofs of these six sequences. Let's see in sequence number 1. The first thing is in sequence 1, we have limit n approach to infinity as then sequence approach to tends to 0. Let's see how. The sequence, it's our sequence, and sequence, it's our limit at n to infinity, and it's a sequence log of n over n. Applying the limit both sides, we get this. By L'Hospital rule, take the derivative of numerator and denominator separately, we get 1 over n. And when n approach to infinity, then we get 0. 1 over infinity is 0, so the sequence tends to 0 as n approaches to infinity, and the sequence is convergent. Similarly, as in sequence number 2, here we have a sequence, and let's suppose the sequence when limit applying both sides, we said let y is equal to limit n approach to infinity n power 1 over n, taking log both sides. And next we know after applying log, and we know log and limit are commutate, so we can write limit first and log after, and applying the log property here, then applying the L'Hospital rule, and we get 1 over n, and 1 over n when n approach to infinity, we get log of y is equal 0. Next, as we know, we need just y, so applying the exponential both sides, we get y is equal to 1. So this means that this y, actually the y is nothing but y equal this sequence, so this sequence is gonna 1. This sequence is gonna 1 and sequence is convergent. Next we have sequence number 3 with the condition x greater than 0. In the given sequence, as in a previous sequence, there is just a one thing difference. In the last sequence we have n power 1 over n, but in this sequence we have x power 1 over n, taking limit both sides, and let y is equal to this sequence, taking log both sides, same property used in the second question as it, and at the end we get y is equal to 1 by exponential, so the sequence approach to 1, it's convergent, hence proof. Similarly, the sequence 4 with this condition, and the sequence is this. If condition was not mentioned, then this sequence is directly undefined, because this sequence, this with this limit, this sequence tends to undefined. Okay, because it may be three cases. If x is equal to 1, if x less than 1, and if x greater than 1. With these three cases, this sequence tends to undefined, but in our case we have mentioned this condition. According to this condition we get 0, so sequence is convergent. Next we have sequence 5. Sequence 5 is also with the condition for any x, no general condition. Sequence is this, and applying limit both sides, taking the power first in log, and then simply applying the L'Hospital rule, and we get this, and taking, because limit is only on the n, so taking x outside of the limit, and then as n approach to infinity, and this we get x. But we have log of y is equal to x, we need e power x. E power x, taking exponential both sides, we get y is equal to e power x, and the sequence is e power x. Similarly, sequence number 6, we have this sequence, taking limit both sides, separate the limit upper and lower, and denominator and numerator puts the limit separately, and this sequence we know undefined. So but this sequence tends to infinity as n tends to